define behavior that makes sense and can make the units look very realistic, very humanistic in their behaviors. When would you search for a path but not know the final destination? So this could be the case where you have a starting point. Let's say you're at point B, and at all these other points there's some sort of resource that you need, a health pack, gold, what have you. And so you know that you need this item, but you don't really care which one of these nodes you go to. You just want to go to the closest one. So in that case, you actually have multiple possible end states, and you don't really care which one you're getting to. What search algorithms are appropriate when you know the final destination? So actually, just going back to that last question, breadth first search or Dijkstra's algorithm makes sense when you don't have the final destination, because you're basically weighting them all equally. I mean, obviously they have different costs to get there, but the value once you get there is the same. So you could do a search to try and figure out what is the best one to get to. What is the best route to get to whatever destination you're trying to get to. What search algorithms are appropriate when you know the final destination? So in this case, you know exactly where you want to get to. Dijkstra algorithm still works really well in this case. But as I mentioned, A star can work better because it's more optimal in the solution that it finds. You can take into account some data that you know about the environment. Also, the book has a really great picture about this, whereby you can see that when you're searching around using Dijkstra's algorithm or breadth first search, it's relatively it's not very focused in this direction, whereas with Dijkstra's algorithm it is very focused, and the same can be said for best first search. It goes in the right direction first, doesn't waste a lot of time going in the opposite direction just because that path happens to be the same weight as the path in the right direction. And then the last question, when would pathfinding involve moving other agents? So this has to do with the path following. So if another agent happens to be blocking your optimal path, then you might consider moving it. One way that you might want to approach this is to not mark off those nodes that are already occupied as being off limits. You may just want to provide, or rather mark the cost to going through that node as being much higher. The book says 3 to 5 times higher. That way it's still possible, but you want your algorithm to actually search around and see if maybe there's a relatively close path that has that works. But if need be, it will still find that path causing the first unit to move. It'll just it'll try and search around a little bit more, and it'll know that that's not the optimal way to go. This takes into account the fact that you're going to have to figure out where to move this other agent to. It's going to take time to do that. There is a cost associated with that. So that is chapter 6. If you guys have any questions, feel free to contact me.